make one solid out of everything. 2, the Boolean expression intersection makes one solid that contains the intersection portion. I scratched out the end of this because it's false. Now, some people took off intersection and put the new one up there, interference, and then this statement would read correct. Okay, so there's a couple ways to go about that. Any questions on that one? 3, the Boolean expression subtract makes a solid that contains the features of one solid minus the features of the other. That one's false. If the solids that you're selecting in both of these processes don't intersect, what happens? So I select a solid, I select one to subtract from it, but it doesn't intersect it. Yeah, it's just like deleting it, right? And my original solid would not be affected. 4 is true. You always subtract the one from first. 5 is true. To create a new solid from an existing solid, you hold down the control key, select a face, then use extrude. That will create a new solid. Can I use anything besides extrude? Can I use revolve?
Yeah. Revolve.
Sure can.
Sweep.
I don't know that sweep.
Because you have
I
the
haven't tried
face.
that one, but you need to have some type of path to work on it. I'm not really sure about that one. Number 6, if you wish multi-view drawings to remain interactive with your model, use the view base display option. That is true. 7, the command solid edit allows the drafter to alter the shape and color. Yes, that's true. 8, 9, and 10 are all false. Sole view, sole draw instead of view base is that the 2D line work is not interactive. As soon as you run the sole draw command, all of that line work is now independent of the model. So we can draw over it, right? And edit two-dimensionally. The loft command uses a single close P line. A lot of people fix this by scratching out loft and using extrude, which is fine. But if you're stuck with the loft, you need at least 2 closed P lines to loft. 10, sub-object selection. Hold down the control key. 11 and 12 are true. A polygon may be revolved around. Why can we do a polygon? Why can we make a solid out of any polygon? Because it's a closed P-line.
Yeah.
Even if you use the polygon command, right, that does a hexagon or something, it's a P-line. Therefore, you can use it. A rectangle is a polygon. Those are all P-line based drawing objects.
So why its definition of polygon is closed?
Yeah. It's closed shape. To create complicated objects, you usually draw them. Arcs and lines, make a P-line of them, and extrude them. Certainly that's true. 13 is your dynamic UCS. It's false. It's not dynamic draw. It's dynamic UCS. And keep in mind that's on your status bar. If you have it turned on, anytime your cursor goes over a plane, it recognizes that plane and you're drawing on that plane, as long as you hold your cursor in there. This one seemed to get a lot of people. AutoCAD considers the default drawing area to be the front view. Okay, this is false. What's the first step we do when we open our templates? Switch it to the front, because every AutoCAD drawing you're going to open is going to open to the top view. Every one.
Oh, that's what the NSA views.
It's really on the top view. As soon as you open any of your templates, it's on the top view. Or you start from scratch, you're in the top view. Yes?
And you can't set like your front view to be a default?
You
And
can
instead-
set your templates to go to those views and save them that way, and then they will open that way. The last one is false. When we go through all 3 dimensions, we need the sweep command. Any questions on those, or do you want to discuss any of them in more detail? All right, the next one, so this was just recognizing which Boolean created the shapes. So if I have two solids and I run a Boolean operator and I'm left with one solid, that contains all the material of both items, I'm using union. If I create a solid that has one solid minus the other one, I'm using subtract, and then intersect was the only common area between the two, which is this cylinder right in here. Any question on those? And again, your 4 creation items here. Kind of figured these were gimmies.
Yeah.
If you didn't get these, you probably should go back through them, because if you don't have these 7 things kind of figured out, you're not going to get very far with 3-dimensional drawing. Yes?
Is a sweep and a thread the same, essentially the same thing, or no?
A sweep and a what?
A thread, like the thread
Well, you
command?
use the sweep option to create a threaded fastener.
Mm-hmm.
They're not the same thing, because you can use sweep to do a lot of different things. It's the only one that allows you to go all 3 dimensions at the same time through an extrude operation. Okay. Okay. All right, so here's my coordinates. Right here. There were 3 points, and so I just checked them. I took 1 off if you missed 1 of the 3. If you missed 2 of the 3, I just marked the whole thing off. Oh, excuse me, there were 2 points each. So, first one's 1, 3 minus 2, B, 2, 1 minus 2, C, 4, 1, 0, D, 4, 3 minus 3, E, 0, 3 minus 3. Any questions on how I got those?
Please show.
Yes, I will. Okay, first thing, as you look at this was really looking at the right-hand rule in your Cartesian grid, of course. Where's your origin? Right here?
0, 0. Right
Which
there.
way is the positive axis is going on those origins?
Positive this way, negative that way.
Z is positive this way, X is positive this way, Y is positive this way. So in essence, really, X and Y have to be positive in every one, because I'm using my X grid coming this way. I'm going positive all the time. My Y is always going positive. Every one of your Z values has to be negative, because this is the positive direction. Or 0. Or 0, thank you.
Yeah.
Okay? And I think that's what most people missed, is that part. And so if I went to like point C, okay, I would know I'm going 1, 2, 3, 4 in the X, 1 in the Y,
Yeah.
0 in the Z.
Z.
Now, if I'm doing B, okay, I'm going 1, 2 in the X, and you wanted to follow this, it's an isometric. So you come here, here, and then I'm coming this way. Well, this is minus 2, this is a positive 1, and that's a 2.
And then your X is 2, your Y is 1, and your Z is negative 2. Okay.
You kind of see that?
Next, so on the Z, why aren't those, the 4 slots on the far right? I mean, I thought that was negative, 1, 2, 3, 4.
They are.
They are.
It is.
They are.
This is
So B
0.
would be at 4
Minus 1, minus 2,
or
minus 3.
3.
Yeah, because
No,
if you were
that's
to
two.
draw a line up,
Because you can't just draw straight over to it like this. All this supposed to make it come down at a vertical, it comes down and extrude. So for this one, so this is at 2 because it comes over to 2, straight up, and then over to that angle.
I get it.
Because this is an isometric view. And so you can't
yeah.
straight over, you remember that movie on, the house?
Oh, like that. Oh, yeah, I get it.
Okay.
Because you can't go all the way back down.
And so we stop at this point, so then we go straight down on that point. Does that make sense now?
went ahead and wrote the numbers up here.
Can you go down and see your check? Can you, so you can see the top of the answer check?
Yes. Missy, is there any of those you want me to kind of trace on there for you, so you can see where they come from?
Yeah, you can do any of them if you want.
Yeah, I want to do messy. I totally-
You pick, cause, B I get now,
Here, Lisa.
so then,
Now, you saw this
C,
grid in a couple
B0.
places, and let me maybe throw this out there, is that chapter 2 of your AutoCAD section, they talked about three-dimensional coordinates. In your Bertolini text, chapter 6 had a pretty extensive talk about Cartesian coordinates in this dimension also. Okay, I believe it was 6 right at the start. All right, so let's look at D. So D, okay, it's on the edge of this object. Okay, we're following isometrically, so therefore my x value is 1, 2, 3, 4. And we write these with x's, and that's what the instructions called for, so it's 4, comma. And then I'm going up, okay, I'm to the top. Well, here's my grid here, so I'm 0, 1, 2, 3. So that's my y value. And then on my z value, here's 0. I'm going -1, -2, -3. So there's the coordinates for D. To do A, right here, you just follow these over. I'm 1 over, because if I take that and kind of bring it straight up. Okay, so my x value, this is D, A is 1 dx. It's all the way on the top, so 1, 2, 3 in the y. And then this plane right here, you kind of see it right here. It's -1, -2.
cause you follow that all the way over and then just down.
Yeah. So it'll be here, here, and you're gonna hit right on that. Okay, let's just kind of stop there. I would suggest that you review those 2 sections. I don't have my Bertolini text up here, but I'll check it and give you some page numbers. And I think that's really maybe a better expose than what you see in the AutoCAD text. For your extra credit, this is what I was really looking for. Wireframe has no volume, no mass. You're defining the vertices, right? Our 3 types of solids out there. Surface has volume, no mass. I use the analogy of a cardboard box because it's empty inside. And then a solid has volume, has mass, or the exact digital replica of the object. And you got 2 points for each. Any questions on those? Okay. Can I get those back, please?
So do you understand which way
Is that up here?
Yeah, I made a copy of it if you want.
Is this,
You get it, though?
put that in this here.
No, you do.
Because like you look at it, because you know that that's drawn.
I always draw my box around, and then I figure it out.
That one comes straight down there. And so you came over, because you have to treat this as anything along this line, because this line goes this way, anything on that line, figures